In this really brief introduction to what is on the page below, I just wanted to walk through each section, tell you what it's about, tell you about how much time we should spend on it, and then move on. Now you can see here I say that the page has three very different sections: what we mean by a limit in multivariable calculus, what it means to be a continuous function in multivariable calculus. In both those we're not going to take a lot of time on. And the three ways we try to evaluate limits of multivariable calculus, which is what we're going to spend the lion's share of time on. You can look at the first section. It says limits of multivariable functions. If you look at the definition, you can see that definition is almost identical to the one that we actually see in Calc 1. So you can see that there should be a hole in the graph, there should be a height, and if we say that the limit is actually equal to that value, if we can force the function values f of x, y to be as close to the height of that hole as we can by choosing points as close to our point as we have to. The definition of continuous function is almost, again, identical. And if you look at it, what you're going to see is that it's continuous if the height of the hole is equal to the height of the dot. In practice, we use this exactly the same way we did in Calc 1. And that's what number 2 is about here. It says most of the functions we deal with are combinations of functions we already know are continuous. So even if I deal with functions like this horrible function here, as long as someone says, take the limit and we can plug in the number, the answer we'll get when we plug in the number will be the correct limit value. We are going to do some examples below, but that's all this thing says. It's exactly the same thing as said in Calc 1. Roman number 3 here says you need to know all of your Calc 1 limits. And if you need practice, go to that section of Paul's online notes. Meanwhile, the procedure for evaluating multivariable function limit really just has 3 sections. The first section says, what Calc 1 techniques can we use? So you have to know those, because if you don't remember them, the other techniques won't work on those. And there's an activity. The second part, and this is actually what usually takes the lion's share of limits in Calc 3, try showing the limit doesn't exist. Well, remember in Calc 1, that meant the limit from one side was a different height than the limit from the other side. This gets taken to new lengths here. It's very interesting. I always thought this is one of the most fun things from this chapter is that when you're trying to take a limit and show it doesn't exist, you have to walk on the surface from different directions. Well, now, instead of just a left-hand side and a right-hand side, there's an infinite number of directions that you can walk to that point on. So it's more interesting and it's more fun, and that's what we'll actually spend most of our time on. And there's an activity to do. The third is showing a limit does exist when Calc 1 techniques won't work, and we're pretty sure the limit does exist. There's a nice Wiley Plus video. We will do another example. We won't be spending a lot of time on this, but if you are a math major, this is probably the most important one on the page. That's all we're going to do now. We're now going to start going through the limits and the videos and the activities from the 3 sections.